Hello. Let's talk about the homework for Project 1. All of you are doing a really good job, and I would just like to cover some common question you make, common mistakes and some configuration or setup. Maybe someone may have issue with them. Okay. Ah, that's the template. Okay. So now I'm linked with the remote lab Tompkins 4.6, and I'm open the homework document and also our SMP cage. And let's take an example using the task 4, okay, influence of the block size. Okay, and for the configurations, we still have these three things, right? And firstly, let's set everything in default. Okay, so according to the table, we will set the memory organization use SMP, and the processors will be one. We are the single processor, single cage, and the protocol will be MESI, and using the random, right? And then we will doing the word Y to be 32, and we need to maintain the main memory size to be that's actually 1 MB, right? 1024 KB is a 1 MB. So since you know the main memory size should be the multiple with the words by block and blocks in main memory, and since our what will be configured is the words by blocks will vary from 8 to 1024, 1024. So let's start with 8, okay? So it will decrease to 8, and we can double check that the block size is 32 bytes, is that right? Yeah, 32 bytes. And remember, we need to maintain the main memory size to be 1 MB, and here is 16, so we need to decrease the blocks in main memory, right, into 1 MB. Yeah, it says the number of blocks in main memory will vary. So here we have finished the setting for the main memory, and then we go to the caches. We'll see the mapping will be fully associative, and using LRU, yes. And remember, here we need to the cache size will need to be changed by changing what the blocks in cache, right? So we change the blocks in cache from, okay, start with cache size 4 KB, okay, yes, and LRU, yes, okay. And using what kind of the data, that is year, okay, year, click it, assign it to the processor 0, okay, and then capture the data using the cache, okay, and run it completely, and we will see the hit and miss really fast since it's a tiny data set. Yeah, so we will get a result really fast as you did before. Alright, yeah, I think we get the same result. The miss rate will be 23.888, yeah, percent, and we can double check. Task 3, task 4, sorry. Yeah, for the basic configuration is the 23 and 88, the miss rate. Yeah, let's go through about this task 4, and then we will start from beginning to talk about the other task. Okay, so this will be one of the configurations, and then let's try another, right? We want to try the like 1024, 1024 of the words by blocks. Okay, words by blocks will change into 1000. Oh, yeah, and remember, we need to maintain the main memory size to be 1 MB, so we need to decrease the blocks in main memory, right? So like here, and then we need to change the cage size into 32, okay? And so we will change the blocks in cage, decrease it into 32, okay? And the trays are the same data, so we will just run it, okay? It should also execute really fast, and if we are successfully, then we should get like 2.47 or 2.37 the miss rate. Yeah, here I just want to tell you that we need to maintain something by changing others, like changing the blocks in main memory and change the blocks, words by blocks. So you need to have a you need to know that the main memory size are related to these two guys. So that is how we can maintain it to be 1 MB. Okay. Okay, yeah. 3.37. 3.37. Yeah, we are correct. So this is how the configuration. We need to change the variables to maintain something constant, right? And I think all of you are doing the really good, so I just want to cover it really quick. Okay. And okay, let's go back to our template or result. Yeah, for the task one, all of you are doing a really good. There we get the best locality grade, or you can say the lowest miss rate is CXP, and the worst, the bad is the SWM. Okay. Yeah, and it try to exploit the locality, and yeah, it is because the compulsory the miss will decrease and decrease, and in the future we just have the capacity miss. Remember, there are no conflict misses in the fully associative, right? We are using the fully associative mapping, so it's a really important things or features that you need to know, that the fully associative mapping will not have the conflict misses. Okay, so go to task 2. We are also using the fully associative, and yeah, the miss rate should decrease, right? And you can say that for question 2, the decrease is happened, but it will it is decreased for every trace files, but it should depends on different localities, right? And for the capacity, it will decrease, right? But the conflict, remember, we are using the fully associative. There are no conflict misses, and yeah, no conflict. And yeah, because that for question 5, why is it stable? Because there are no more capacity misses. I mean, the capacity misses will be really small, so the changes of the miss rate will even no change, right? And yeah, when we increase the cage size, we will have more capacity to load the most frequent fetched data, so the capacity misses will decrease. So yeah. And 7, you can say that it is different. It is not at the same point, right? Not definitely not totally at the same point. So yeah, and conclusion is, yeah, it is improved the performance generally. Okay, and go to task 3, still fully associative, and what is it? Yeah, the miss rate will decrease, but after a certain point it will increase, right? You can see it will decrease until the word by blocks is 255, and then it will increase. right? Start with the block size, word by block is 512. So you should tell me it will decrease initially and then it will increase. You can say it is happened generally. Yeah, everyone is decreasing and then increase. But can we see anything different, right? Depending, well, which one will increase first or later? I think everyone will increase, start with the 512, right? Yeah, I think so. So yeah, it have a general trend that increase in the start from word by blocks 512. So for the compulsory message should be decreased, and for the pollution point is that we are too big enough. We are too big, and then there are some data that is will increase that will make the miss rate increase, that due to there are more useless data, so the hit rate will decrease, that makes the miss rate will increase. Yeah, it is appeared. And for conclusions, you should tell me that it depends, right? Initially the miss rate will decrease as you increase the block size, but if the block size is too big, too large, then the miss rate will decrease, will increase. So you should tell me it's depending things. Yeah. For task 4, still fully associative, and yeah, we are asking the same thing, and you can see the same thing. I mean, block size increase, right? So you can still see that when we are using the same case size, when the word by blocks, I mean, the block size will increase, so the miss rate will initially decrease, right? And then increase, decrease and increase, decrease and increase. And how about the compulsory? Yeah, surely the compulsory will decrease when we make the block size larger. Yeah, sure, it will still have the pollution point. And how about the influence of the pollution point? Yeah, the influence of the pollution point is that does it make the miss rate even worse and worse? You can see that the influence of the pollution point is getting not that big. I mean, the influence will decrease as the cage size increase, because when we are having even a really large cage size, then every data we can cover. So for some data that is not that, every data will be covered in the cage. So when you increase the cage size, it will make no influence of the data already inside the cage, right? Because every data are already inside the cage, so you will just leave more blank block, or yeah, blank block, the empty block. So yeah, that is the influence will decrease. And go to task 5. Okay, so here we will try to find the mapping policies, how they influence the miss rate. So the miss rate will decrease, right, as the associative increase. Yeah, it is decreasing, and the conflict misses will decrease as the associative grade increase, because when we increase in, you can see from like direct into the fully, the features is that the fully associative, we can just map, or we can just say every data can map into every cache line, so there are no even less minimum the conflict misses. But direct will have a really strict limit that 1 should go to 1. Yeah. So the conflict misses will decrease. The influence of the associative grade. Actually, you can see the improvement, right? From direct to the two-way set, it is increased. I mean, the miss rate will decrease by I think 33%, right? From 12 to 8. But you can see from 8 to 40, there are even really tiny increase. I mean, the decrease of the miss rate. So the influence will decrease, right? We have, or you can just compare the start and the end point, right? And yeah, question 4 is that which one give the biggest improvement? That surely from direct to the two-way set. Yeah. And then go to task 6. So the replacement policy, we are trying different replacement policies. The best is the LRU and the worst is the random, right? And for LFU and FIFO, they are doing quite same thing, just similar thing, not totally the same. Okay. And and do they have the same thing for LFU and FIFO? So surely not constant. They depend on different locality grades, because we should say that it depends on the how the data organized, the data structures. So that's the locality grades. For the direct map cache, some of you are really may have confused about when we have direct mapped, how the replacement policy will affect it or not. So the answer is no. Different replacement policy will not affect the direct map caches, right? So yeah, please have a check. Did you understand this? And for conclusion, the best improvement should start from random to LRU, I think. Random to LRU, right? And for other guys, just doing a little, not that really ideally. So the random to LRU, we're doing the best. And for other analysis, you are doing a really good job. So yeah, we just want to cover it, every answers. And okay. So yeah, one thing I want to mention is that you can just say the miss rate. Just tell me the miss rate, because the hit rate is not necessarily after you're giving me a miss rate, right? 1 minus the miss rate will be the hit rate. So yeah, you won't need to like make a really huge table to cover both hit rate and miss rate. Just give me the miss rate, and then you can organize your table really efficiently. Okay. Yeah, here is the part for the homework 4. Thank you.